Hello everyone, in this video we're going to learn how to solve a system of equations using Cramer's rule. Alright, now first we're going to talk about the Cramer's rule for 2x2 systems. Consider a system of two linear equations in two variables. Now step number 1, we need to find the determinants. D equals A1, A2, B1, B2. Make sure D different from 0. If D equals 0, the system either has no solution or infinitely many solutions. So keep that in mind. DS, we're going to ignore this guy right here. So we have C1, C2, B1, B2. Make sure you know how to rearrange this one, right? Now, D sub Y, we're going to ignore this guy. So it could be A sub 1, A sub 2, C sub 1, C sub 2, right? Step number 2, we're going to find solution. S equals dx over d. Y equals dy over d. Now, let's take a look at example number 1. We need to calculate d. It's going to be A1, A2, which is 12, 2. B1, B2, which is 3, negative 3, right? So 12 times negative 3 is going to be negative 36, subtract 2 times 3 is going to be 6, it could be negative 42, different from 0. So the system has one solution, right? Now we need to calculate ds. It's going to be C1, C2, which is 15, 13, right? B1, B2 is going to be 3, negative 3. So 15 times negative 3 is going to be negative 45. Subtract 39, right? Because 13 times 3 is 39. So it's going to be negative 84, right? Now dy equals A1, A2, which is 12, 2. C1, C2 is going to be 15, 13, right? 12 times 13 is going to be 156. Subtract 2 times 15 is going to be 30. So it could be 126, right? Now S equals dx over d, right? So it could be negative 84 divided by negative 42. So it could be 2, right? Y equals dy over d. It's going to be 126 divided by negative 42. It's going to be negative 3, right? So the final solution is 2, negative 3. Now let's move on to question B. We need to find determinant D, right? It's going to be A1, A2, B1, B2. 3 times negative 4 should be negative 12, subtract 6 times negative 2 should be negative 12. It's going to be 0, right? So the system either has no solution or infinitely many solutions, right? Now we need to check to see which one, right? So from the first equation right here, I'm multiply both sides by 2. So I'm going to have 6x minus 4y equals 8. Then I'm going to copy the second equation over here. Now I'm going to subtract this guy vertically, right? So the left hand side is 0, the right hand side is 8, which is not true, right? So the system has no solution. Now suppose I'm going to change 0 to 8. Then the system has infinitely many solutions. Because if you subtract this one, it's going to be 8 right here. So 8 subtract 8 is going to be 0, right? So which is true. Now let's move on to number 2. Cramer's rule for 3x3 systems. Now consider a system of 3 linear equations in 3 variables right here. Step number 1, we need to find the determinants. Now we need to find D first. Print the coefficient A1, B1, C1, A2, B2, C2, and A3, B3, C3 over here, right? DS, we're gonna print this column down first, right? And then we're gonna ignore this guy. So we're gonna print this guy down, right? dy, we're gonna write A1, A2, A3 here. and then D1, D2, D3, and then C1, C2, C3 right here. We ignore Y, right? Now DC, A1, A2, A3, B1, B2, B3, ignore C, right? And then D1, D2, D3. Step number 2, we're gonna find the solution. S equals ds over d, y equals dy over d, and z equals dc over d. Now, if d equals 0, the system either has no solution or infinitely many solutions, similar to the first case, right? Now, let's move on to example number 2. We need to find d. We need to create the determinant A1, A2, A3, B1, B2, B3, and C1, C2, C3, right? In order to find the determinant of 3 by 3 matrix, we're gonna copy the first two columns over here, right? So it's gonna be 1 times -2 times -2 is gonna be 4. 1 times 1 times 1 is gonna be 1. -1 times 3 is gonna be -9. Subtract 1 times -2 times -1 should be 2. 3 times 1 times 1 should be 3. -2 times 3 times 1 should be -6. ds is 6, -5, 14. 1, -2, 3. -1, 1, -2. Then we're gonna copy the first two columns over here. 6 times -2 times -2, 24, right? 1 times 1 times 14 is gonna be 14. -1 times -5 times 3 should be 15. Subtract 14 times -2 times -1 should be 28. 3 times 1 times 6 should be 18. -2 times -5 times 1 should be 10. So must be -3. dy equals A1, A2, A3, which is 1, 3, 1. D1, D2, D3, which is 6, -5, 14. C1, C2, C3, which is -1, 1, -2. Then we're going to copy the first two columns over here. 1 times -5 times -2 should be 10. 6 times 1 times 1 should be 6. -1 times 3 times 14 should be -42. Subtract 1 times -5 times -1 should be 5. 14 times 1 times 1 is 14. -2 times 3 times 6 should be -36. Is -9. Now DC is A1, A2, A3, which is 1, 3, 1. B1, B2, B3, which is 1, -2, 3. And D1, D2, D3, which is 6, -5, 14, right? Now we're going to copy the first two columns over here. Then DC is 1 times -2 times 14, -28. 1 times -5 times 1 should be -5. 6 times 3 times 3 should be 54. Subtract 1 times -2 times 6, -12. 3 times -5 times 1, -15. 14 times 3 times 1 should be 42. Is 6, right? So S equals ds over d. ds is -3. D right here, -3. The answer is 1. Y equals dy over d. dy is negative 9 divided by negative 3 equals 3. Z equals d, z divided by d. dc right here 6 divided by negative 3 is going to be negative 2. So final answer should be 1, 3, negative 2. Now let's move on to question B. We need to find D. It's going to be 1, 3, 2. Negative 2, 1, negative 4. And 3, negative 2, and 6. We're going to copy the first two columns over here. So D equals 1 times 1 times 6. It could be 6. Negative 2 times negative 2 times 2. It should be 8. 3 times 3 times negative 4 should be minus 36. Subtract. 2 times 1 times 3 should be 6. Negative 4 times negative 2 times 1 should be 8. 6 times 3 times negative 2 should be negative 36 is 0, right? So the system either has infinitely many solutions or no solutions, right? Now we need to check to see if the system has infinitely many solutions or no solutions, right? So from the first equation right here, I'm going to multiply both sides by 2. So I'm going to have 2x minus 4y plus 6z equals 0, right? And then I'm going to come back with the third equation right here. Now I'm going to subtract this guy vertically. So it's going to be 0 equals 0, which is true, right? So the system has infinitely many solutions, right? And it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.